Today we're going to be outlining the new DLI control program and how to install it. Click the button to start. Introduction. Topics covered include installation, setup and configuration, summary, and a short quiz. Installation. Before starting these installation steps, you first need to log into the Session Manager and Thin client. For instructions on how to do this, see the Titan 2 System Installation Guide. The following installation steps are outlined in this section. Add DLI as a group. Select a controller. Add DLI either as a window or menu entry. Select window properties if necessary. Load the DLI program into the system. To add the DLI control program, add a group. Click Next to continue. Select a controller. Click Next to continue. Add DLI either as a window or a menu entry. Optionally, select window properties to change the look and feel of the window. If menu entry is selected, then the fields are grayed out. Click OK to return to the Add Group dialog. You can also enter an abbreviation, a label, and a note if they're required. Click Finish to complete adding the DLI program and start using it. The program is now in progress. Once it's finished loading, click OK. It's now displayed on your home screen. Click Display As to have the program as either a window or a menu entry. Setup and configuration. Only one light sensor is required, but two sensors are recommended, both an indoor and an outdoor sensor. An outdoor sensor is used as a backup in case of indoor light sensor failure. The best choice for indoor is a PAR light sensor mounted at crop level under the lights. If you only assign an outdoor PAR sensor, the program has to estimate the actual light received by the crop based on the program settings for transmission efficiency, curtain use, and lamp output. When you use an in-zone light sensor, make sure it's mounted on the lights. The sensor detects the actual light from all sources, and the program accumulates a much more accurate DLI value. Accurate transmission efficiency settings. The DLI program uses this to predict the potential DLI available from sunlight for each day, so it needs to be reasonably accurate. Start with a value between 40 to 60%. If you have an outdoor PAR sensor and an indoor PAR sensor, it is easily calculated. The best time to do this would be to observe the transmission efficiency, or the difference between outdoor and indoor as a percentage of the outdoor value, from 2 hours before midday to 2 hours after midday on a clear day in summer. To calculate transmission efficiency, use an indoor and outdoor DLI as it's more accurate than instantaneous light readings. You may find that before and after these times, and at other times of the year, the transmission efficiency is reduced significantly due to additional surface reflectance. Provided you have indoor and outdoor PAR sensors, you can also monitor and record the actual transmission efficiency any time that the lights are not on by running a separate efficiency calculation in a math matrix program. Seasonal light intensity model. The accuracy needs to be reasonably accurate but not perfect. The DLI control program needs to predict the DLI potential for each day. This changes with the seasons based on your location. The linked seasonal light intensity model calculates the day length for your date and location and the maximum light intensity for each day based on user configurable maximum light intensity settings for each week. This model uses a light intensity table to capture the maximum light intensity for specific days as displayed. From this, it derives the potential DLI for each day. It automatically calculates the maximum expected light intensity for your location. The expected maximum solar intensities are filled in using the Solar Spectral Calculator utility for each week. This utility is found on the Seasonal Light Intensity Model screen. You need to record and observe the maximum light intensity at midday on clear days and adjust the model settings accordingly. Inability to achieve a consistent DLI. Here are some things that can cause problems achieving the target DLI. If the total amount of sunlight received plus the total amount of supplementary light delivered during the lighting window time cannot achieve the target DLI. When sunlight alone exceeds the DLI target, whenever there is no post-dusk supplementary lighting window or an insufficient post-dusk window. It makes it harder for the program to achieve an exact DLI target because there's not enough opportunity to run the lights after dusk if the program is still a bit behind on the DLI target. If the predicted maximum DLI from the seasonal light intensity model is highly inaccurate for the location and date. If the various configurable overrides and limits in the DLI control program interfere with the basic DLI algorithm, configurable overrides include DLI cutoff, photo period, or external logic programs. Excessive shade curtain use. If you use a PAR light sensor in the crop, the DLI program senses this as less sunlight and it tries to respond accordingly. If an outdoor sensor is used instead, the program recalculates the potential DLI based on the current shade curtain settings. The topics we've covered today include installation, setup and configuration, summary, and a short quiz. Next is a short quiz on the concepts you've learned today. Thanks for watching the video. For more information, see the DLI manual or datasheet or contact Argus support. Click any of the following links for more information.